right, this is question 3 from Unit 2 on the midterm review. And this will just ask a lot about information about this function that's given to us. So if we take a look, for A, it wants us to find f of -4. So you go to your graph, go back to -4 on the x-axis, which is right here, and find the point that corresponds with that, which would be up here. So f of -4 would have the y value of 5. F of 0, here's 0 on your x-axis, that would also have a y value of 5. And f of 5, the count's all the way up here, so let's see here, 10, 11, 12. For part D, it asks us to find x when f of x equals 0. So remember, f of x is just a notation for y. So if you look at your graph, the only time where your y coordinate would be 0 would be on your x-axis. That would have the point 0, or not 0, -5, 0. So the x-coordinate when y is 0 would be -5. E is a similar question, except instead of asking when y would be 0, it's asking when y would be 8. So I think the easiest way to do this one is to go up to 8, so 5, 6, 7, 8 on your y-axis and draw in a horizontal line. And then wherever that horizontal line hits, all of those x values would be your answer. So if you take a look, let's see here, 1, 2, -3, -1, 3, and 7. So we can just list those out. If you want to find the absolute maximum, you're just looking for the highest point on your graph. There's nothing that says anything about like what the shape of that has to look like. So I'm just looking for the overall max. It's this point up here. So that would be the point 5, 12. And same thing with absolute minimum. You're looking for the absolute lowest point on your graph. Now, if you can see, we have this arrow that's going to go down. All right, and that arrow is going to continue to go down forever. So we can't really pinpoint one specific y value that's going to be the absolute lowest. So whenever you can't pinpoint a specific point that's going to be the lowest, there technically is no absolute minimum point. Now the relative max and mins, those are the ones that we have stipulations on what the shape of the graph should look like. Or relative minimums look like a valley in a graph. So it has to have a change in direction that looks like that. So if you look at our graph, we have, if you kind of trace along, we have one of those. It's right there. It's at the point 1, and then 1, 2, 3, 4. Relative maximums, I always think they look like the top of a hill or a peak. So if you follow trace along your graph, we have one here. So at -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we keep tracing, we have another one here at 5, 12. So as you can see, sometimes a relative maximum can also end up being your absolute maximum. It doesn't happen all the time, but it is a possibility. Your y-intercept, moving on to part J, is just going to be the point where your graph hits the y-axis. So right here, 0, 5. Your x-intercept is going to be back here where it crosses the x-axis. So -5, 0. And last but not least, domain and range. Domain, remember as you look left to right on your graph. So if you look, as we trace along our graph to the left, this graph down here, I mean, it looks like it stops here, but since we have this arrow, we know that this graph's going to continue to go down, and it's going to continue to go to the left. So since it goes on forever in both of those directions, domain technically starts back at -infinity, and we always put a parenthesis with infinity. And then as we go to the right, where it stops is here, and that's at the x value of 8. Now before we put a symbol on 8, we have to look at the point there at 8. Since it's an open point, it doesn't technically equal 8, it just gets really close to it, so we're going to put a parenthesis. Had that point been solid, we would have used a square bracket. So we look at the range. Range, you want to look low to high, or down to up. And if you look, the lowest point this graph's going to go to, again, this arrow is going to continue to go down forever. So there's no low point, so it's going to go down to negative infinity. But the highest point it reaches is here. So I always draw a line over to the y-axis to see where that stops, and that's up at 12. And since there's a regular point up there, we're going to put a square bracket.